my another video for Form 4 Chapter 2 in Physics, Kinematics. Now previously on the left, I'm showing you on how do you memorize, or how do you get to know those 5 equations based on the graph, okay, and also acceleration. Okay, now they will give me an example. How does it work? Now, what I have here is an example for ticker timer. Yeah, the tape on ticker timer, and there are a few things you need to know. First is that the frequency. Okay, frequency is a scalar quantity. They just let you know of the magnitude. So it's only value 50 Hertz. So meaning the needle on the ticker timer is going to oscillate 50 times per second. Meaning 1 second, they are going to have 50 movement. So meaning from dot to dot, any dot from here to here, any dot, the time is different. Distance is not the same because it depends on how fast you pull the tape. Okay, so between dot to dot is always, therefore time period or time is therefore 1/50 second, based on the fact that frequency is actually 1/t. Because of this, 1 time 1/t. Okay, I'm going to find out between dot to dot 1 time. Okay, how long does it take? So we bring up t, bring up frequency. Therefore, time is about 0.02. It's it's not about. It's actually 0.02 second dot to dot. So maybe you're new to this. Maybe you're not familiar. Like it or not, just let you know this distance. If this distance you measure, and I'll tell you this is about 5 mm. Okay, the time from this point proceed to this point is 0.02 second. Meaning, if this tape is if it were to be placed onto the trolley, it moves to the right, pull to the right, it is moving at a very slow direction, very slow speed to the right. Velocity is very slow. 1 second, 5 mm. Okay, 1 second. 0.2 second, 5 mm. Likewise, here, not extreme, 1 to here, maybe I would say the distance is about, well, you measure it at the middle, from middle to middle. Distance is, maybe 25 an inch, 25 mm. Okay, so therefore, I'll be able to find out what's the speed, initial speed, and what's the final speed. Okay, dot to dot, the time is the same. Okay, because the frequency is 50 Hertz. So you'll be able to calculate a few things. First, you'll be able to calculate initial velocity, as I've mentioned in my previous video. U is initial speed. Since I know direction to the right, so I just find out what's the speed. So therefore, initial speed, so it's always distance over time. So the distance is 5 mm over 0.02 second. So it would turns out to be 500 by 2 is about 250 mm per second. Okay, final velocity v on the left is 25 mm over 0.0, depending on how many dots. If your distance is not 1 dot, 2 dots, then 1, 2 dots. So what happened? You divide 0.04, because each dot, the duration is 0.02. If there are 2 dots, 2 spaces, then it's 0.04. But since it's 1 dot, so I will make use of this. 1, 2, 1, 2, 1250 millimeter per second. Well, here we are still not used to SI unit, because the unit given is mm, so I will make use of mm. So now there are a few things you can do. Okay, no, not a few things. These are the things I want to show you how to make use of those variable. So initial, final, time. Then they ask for what's the velocity, or what's the acceleration, a. So a, from what you have on the left, is v minus u over changes of time. Okay, so changes of time is what you need to really called focus at. Maybe you are still new to here, you have no idea. Change of time is actually, this is actually what? The gradient from a curve. Yeah, it's gradient, so change of time. So how do you do it? So first of all, you know my final I've calculated is 1250. My initial is 250. So the change of time, what does it mean? Yeah, how many change of time? So let me brief you out on it. Change of time will be how many changes from here to here. So it's 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay. So there are total 9 dots. So there are total 9 dots. So there are 9 changes. So all you have to do is you times. Yeah. You times 9 times 0.02. Okay, millimeter per second per second. Okay, so therefore your answer, your calculator, what do you get is simple equation 1123 by 9 times 0.02 turns out to be quite huge number. Maybe I would say it's 5.5, 5.56. I change it to meter per second per second. Okay, this is how you do it. So if you have gone through it, you're not clear, you may pause this video, rewind to previous minute, go through it again, and at the same time you may go through your reference book. There are quite a few examples to show you how to use it. Practical questions is will tell you a car or a driver car drive or reduce or increase its speed from what to what after certain duration. Find out what's the distance travel. Then you should be able to tell. Should use maybe equation 3 because it tell you the speed and time. Then you're able to find the displacement. Otherwise, you just need to be familiarized. Okay, each of this equation is lack of one quantity. Yeah, for 5, for example, you have velocity, you have acceleration, you have displacement, but you don't have time. So question that doesn't give you time, then you use this equation. Yeah, sometimes you need to ask for what is acceleration. They let you know what is the velocity, initial velocity, final velocity, initial velocity. Then you know the distance. Then they ask for acceleration. Then you know. You use equation, 5th equation. Okay, this is briefly how you should tackle those questions. How you start off with, and by looking at ticker tape, direction to the right, you will find that this car is moving from very slow to very fast. Then therefore it's accelerating. That's why it is positive. Yeah, so it's accelerating. Okay, from very slow to very fast. Okay, so I think I shouldn't drag too long, otherwise it will become very boring. So next, that will be the displacement time curve and velocity time curve. Now what you have here on the left is velocity versus time curve. Okay, straight line curve. Now what happened next would be they tells you the overall. Yeah, it's actually the overall process. Okay, so briefly, displacement time curve or motion what do you call this, motion of motion, yeah, the graph for motion. So what you normally have would be x and y axis. Okay, I try to put it into straight line, but doesn't work out that place because Now displacement, something you need to know about displacement and time. Time, you know what is it? Second measure, 0. Now, what is displacement? Displacement is always with reference. Yeah, you will learn it in maths also. Okay, say for example, in a straight line, an object from origin. What happened? It travels. An object travel to the left, then come back to origin, and then turns around and stops here. Okay. So how do you measure? What's the displacement? Yeah. So the displacement is always reference to origin. So here to here. Therefore, this will be a displacement. How far from origin? Unlike for distance, distance will be the overall distance. From here, distance will be here to here to here. This is what you have traveled. So this is a distance travel. Okay. So this is the distance travel or distance. Okay. Whereas displacement is always reference to it your origin, from where you have started, how far from where you have started. Okay, so say for example, here I have displacement time curve. So meaning the start from 0. What happened? The plot, therefore it is going away. So it's going away from the origin, because as time increase, displacement from the origin increases. So what happened? Then later they stay constant, straight line, flat line. And then what happened? Next we'll have very steep line going down. Okay. Then a few things you should know is what happened here. Now based on what you have seen over here, displacement over time, from here, this point to this point, the changes of distance, this is actually the changes of displacement, changes of time. Say here is t1, okay, 0 to so this is t1. Okay, so what do you have? This is actually a positive gradient, isn't it? So therefore this gradient is actually velocity. You have changes of distance or changes of displacement over time. So what do you get? The speed increases linearly. Then what happened here? You have a flat line. Okay, you have a flat line. What happened? You have a flat line. So s is 0, isn't it? There's no change in displacement because it's always the same value. Right? Agree or not? It's always the same value here. Say this value is 10 meter. Okay, displacement s in meter. Okay, this is t s in second. Okay, symbol unit. Okay, so the initial point, final point is always 10 minus 10, 0. So therefore v here is 0. The flat line 0. How about here? Next part. This is negative gradient. Correct. So what happened? Negative gradient. So here, therefore, have negative v. What does it mean? What does it mean by negative v? Negative v, negative velocity means it is in opposite direction, meaning it is opposite direction. So it will be maybe your object here. Okay, so can't use this. Yeah? So maybe initial is here. Positive meaning to the right. Then to the left. Okay, stop here. Okay. Okay, so this is where I have v0 not moving for a short moment. Okay, but here tends to be very long. Okay, so this is negative v. Negative v. This is positive v. Okay, so this is what it means. Negative means it is going back. Okay, and here is a turning point. That's why v0 you need to stop for a while at rest. right? This is all about it. Okay, next, very simple for displacement curve. Likewise, you have more information if you get velocity time. Okay, for velocity time curve, you get more. Okay, t is a symbol, s is a unit. Okay, velocity time curve. For velocity time curve, okay, let me give you an example, short one and simple one. Okay, again from 0 it goes up, then again the same profile, you get different meaning. Yeah, if your curve is velocity over time, the meaning will be so much different now, because if you look at the gradient, what happened to the gradient? Yes, to the right, your gradient is now A. It's actually positive gradient. How do I know? Because acceleration is always v minus u over t. Then how do you know? So therefore you start with here, so this is your u. You stop here, so therefore this is my v. So v minus u. Here maybe my t1. Therefore is my acceleration. This is positive. Meaning it is accelerating. Okay? From 0, accelerate. Then what happened in between? Here, between 0. What does it mean? Flat line, you say 0. It's no, huh? What happened? V is 0, yes. This is V, it's not 0. V is constant, isn't it? Constant over time, yeah? This time until t2. Okay? Always the same value. If it were to be constant, what happened? If V1 is equal to V2, it means V is equal to U. If V equals to U, what happened? Then you subtract negative 0. Therefore, acceleration equals to 0. It's not accelerating. It's not accelerating doesn't mean that it's not moving. Not accelerating meaning it is moving at constant velocity. Okay? Take note of this. Then it goes down. So what happened? So here you have acceleration to be negative. You call it deceleration. Okay? You have negative value, because if you're talking about this graph, what happened? Here will be my u, here will be my v. You're looking at this portion only. So the third portion here, I start off here, look at here, this is u, this is v. Okay? So therefore you get negative, meaning deceleration. Okay? Deceleration. That's all about it. Yes, basically, but no. What happened? From this curve, yeah, I think I've shown you in my previous page how do you get those equations. Here I have what? The area, isn't it? The area under the curve. The overall area. Huh? There are a few more. I mean, this is the, something that you should know. Okay, the total area. Total area under the curve. Under curve. It's actually distance travel. It's actually d. Okay. It's actually d. It's actually distance travel d. So therefore, how do you do? You integrate v dt. Yeah. If you are new to this, you may look for my video. I've made a video from 5 additional maths. Go for my blog. I have set up a blog here that lists out all the video, or maybe you may subscribe to my YouTube channel, and then it's free. Yeah, you may look for it from 5. Yeah, chapter 10, I think. Integration to get the area. Or since this is a straight line, it's so much easier. All you need to find out a triangle, area from a triangle, area for a rectangle, and area from this triangle. You just sum them. This case is when the curve is not a straight line. Okay, you use integration. When it's not straight line, then you need integration. Otherwise, a simple triangle rectangle method, I think you'll be able to find out. Okay, if you're not clear, you need more explanation, you may look for your reference text. Okay, but this is a summary. Okay, for what you have need to know. Okay, I've helped you out with this video. I hope you will like it. And you may look for those curve, yeah, velocity time curve, when it is not linear, like straight line. If no more straight line, like say for example, if you have graph that looks like maybe a curve. Okay, you have velocity versus time. Then there's no way for you to find the area, isn't it? By using the standard method. Okay, if you want to find out the area, there's no way. You might at least know what is the equation for this curve. You might at least find out what is this curve. V equals to maybe 2t squared plus 6 maybe. Okay, then only you're able to find out what's the area of the curve. That is for you to really get into it. And you may want to get, how do you get the graph for acceleration versus time? So from displacement versus velocity, all you need to do in order to get velocity curve from displacement, you need to differentiate it. So you differentiate this curve, this curve, then you get a linear. So from displacement, if you have a straight line, you get what you get here. Maybe I will do some extra work here for this curve above. Okay, if I want displacement, I'm going to convert it to velocity versus time. All you need to do is find out here. It's a straight line, right? It's always linear. So what do you get? I will get a straight line. So I will get, so from this is t1. Then this is 0. Maybe here is my t2. This is my t2. What happened here? 0. Oh, so it's negative gradient. So negative. So maybe I'll get a value here. So this is my negative value, negative v. This is a positive v. Okay, this is how you convert them. You'll be surprised that some students are not aware of this. This is, I think, not yet in the syllabus. Maybe they will include it in the syllabus. I don't know. Even there are some pre-U students. They have some problem getting this curve, even up to in their degree. So I hope you will learn it since from 5. Otherwise, you have problem later in pre-U. Questions will be more. Question will be like no longer linear. Okay. Unlike for this case, let's look at this case. You want to get velocity, curve from a velocity curve. You want to get acceleration curve from velocity curve. Sorry, that would be it's very easy if it were to be linear. Mx plus c, right? So here, okay, t s. This is my, I want to get acceleration curve. If I want to get acceleration curve from velocity time curve, another case, meaning if you are given velocity time curve, you are asked to look for acceleration curve. How you do? So first of all, you differentiate. This line, I would say v equals to mx, isn't it? Maybe for t, isn't it? It's straight line, pass to 0. That's why no y-intercept. Correct, for t. So if you differentiate this, you get a constant value. So therefore, it will be a value only, positive straight line value, just a value, a positive value. Okay, this is t1. Okay, t1. Then from here to here, you get 0 acceleration, but constant velocity. That's why I get 0 acceleration. Therefore, it will be 0. Okay, it's 0. Yeah. I purposely draw it higher so that you can see it's t0. It's not that a value, but it is actually 0. Okay, here. Then from here to here is a, you differentiate this line, is a negative value, so therefore you go to the negative value down here. Okay, down. So this is negative a. A and a might be different number. This is positive 6, maybe this is negative 9. Okay. I think it doesn't need to construct that reverse. If you're given velocity time, will you be able to construct displacement time? Actually, yes, unless you know what is the equation. If you know this equation, all you need to do is you integrate. Then you get, you will get it actually. Yeah. But unless you want to do, unless you have learned integration, you will get to learn integration once in Form 5. If you are Form 5 student, I want to challenge you is to get the curve for displacement versus time by using the velocity time curve. Okay, you may name this linear line to any linear line, mx line, y equals mx, or v equals mx, mt, yeah, mt. So you name them, and then you will be able to get a curve actually. Yeah, it's a curve. Alright, I think that's basically all about it. Motion, I think it's quite important for you to interpret motion curve. Okay, and to find out what is the speed, we'll be able to find out the velocity, average speed, average velocity is different, right? Average speed is actually total distance travel, total distance, whereas average velocity would be is the final displacement, how far from the origin. So there's some trick, you know, to do that. I hope you'll be able to find out. Okay, how do you find out the motion graph? I think that's all from me. It's pretty short. If I were you, you will look for this section in your reference from 4. Go through their exercise. Same rule. Maybe 8 to 10 questions. Yeah, 8 to 10 questions of this. Look for it, read through it. I'm sure you're able to comprehend it easily. Okay. I hope you subscribe to my YouTube channel for more video. I'll upload it. It's free of charge. You can do me a favor. That will be to press on thumbs up button. It means that you like my video. It encourages me a lot, especially when you have high viewing rate and cause a lot of people showing a thumbs up value, a thumbs up. Okay. Stay tuned to my next video. Thank you.